I wanted to talk to you about something that sounds extremely technical, with image vector search. What kind of name is that? It is a bad name. I submitted this talk to several conferences, and the only feedback I got is this should be named AI search because it will attract more people. So for the week, I am back. This is AI search. We're doing AI now. Yeah. Thank you. So the whole idea of talking about this individual problem came from like a query that I did on my client's website some time ago. This is apparently the photos of two black dogs, and these dogs are in black, and some of those photos aren't even of dogs. So this is obviously broken, very broken. If you're trying to look for something using tags, it will find things that are two, things that are black, and things that are dogs, but then in any combination. This is a broken search feature. So 5 years ago, if somebody will tell me to use AI for this, we would go to, oh, my clicker is broken. Can I get another one of those? There was this quote that if it's machine learning, it's probably written in Python. If it's AI, it's probably written in PowerPoint. This has changed. Like, there was this like a giant impact moment of AI. Oh, Stephen, not only I mentioned, but also a clicker. Thank you very much. Hope this works. Oh, this is USB-A, so it won't work. Okay, let's just do it from here. But if you have an eye, everything looks like LLM. So if somebody will tell you to write this code for search, they will probably like think of, yeah, is this something like image tagging, descriptions, we can do like a prompt engineering. So hello ChatGPT, describe this image, the format is this, well, we want to see the subject, composition of an image. We want to like generate some description or some tags that will describe the image so we can search for it. In Ruby LLM, which is awesome library, this is very, very simple. Like 3 lines of code and you have a decent description of an image. Unfortunately, even though it's simple to implement and relatively cheap to use because the descriptions aren't that long, not many tokens, and you even get some like a non-visual stuff like this called mood or action scene, we lose a lot of information this way because there is a conversion process between the image, text, and whatever else we have right now for searching. So there are some other anomalies, like a morning vibe or a sunrise mood, are different words. If one type sunrise mood, they might not find the morning vibe, which is terrible. Even if we do synonyms, there is no guarantee that we'll get the right results. And embedding for those tags doesn't really work. Embedding for description kind of works, but it still doesn't describe the image itself. And not to mention text embeddings, they are huge. So you need a lot of space and a lot of CPU power to like go through them. So let's not talk about LLMs for a bit. Let's talk about AI outside of LLMs. Let's shop around for a model. So the first thing that you should do when you're working on an AI problem is you basically Google, because Google works better than ChatGPT for doing those, but this is the wrong phrase. Yeah, appending Hugging Face gives you the real result. And I found this little gem. This is taken before the AI era. This is a very old model, back from the time when OpenAI was actually open, so you can download it. And this is Clip, and Clip was trained on the pairs of images and description, probably stolen from alt text on images. So what it does, it tries to find a matching description for an image from the training set. So if something is exactly description for this particular image, it should be very similar. If something has a description for a different image, it should be very dissimilar. This naive approach works quite well, and they published the entire model. It's a 2-tower model, which is a fancy word for saying like there is a separate model to embed descriptions and separate model to embed images. It was trained on image pairs, and it's English only because they only used English described images in the training set. There is a newer one by Google in 2023, which is around the time of ChatGPT. Also a 2-tower model, they had some better idea to do training, but it's still English only. The better idea is that Clip uses match one description to an image, discard everything else, And siglib just uses, does this pair match? Yes, no. So you can use a lot more compute because you're not doing n times n matrix of possibilities. There is even newer one, which is released in this year, siglib 2 by Google. It is multilingual, so that's nice. And uses a slightly different version for vision and slightly different version for text encoders and, well, tokenization. So which one should we pick? The easiest one, of course. It's good enough. It's at least better than what we previously had. I hope so. If we want to also define good, we have to have a common metric. So the most common way to do is having an evaluation set. You can basically extract the search queries from the previous users. And then if you have those, you can check with A/B experiment if they convert better or not. Try it on internal users first, external later, because these are models. They might result crazy results. But the whole idea is very simple. User uploads the photo, embed it, stored in vector database. User sends a query, embed it, compare to the vector database, and get the photos. There are many different databases for vector stores, like every single one of those. Oh, you probably don't know this one. You probably know these ones, right? Yeah, these are the popular ones. There are also those. So every single database that you can think of probably has some vector search feature. You already have one of those in your project. I choose OpenSearch because that's what this particular client had, and it was easy to adapt. It's very well supported in Ruby. Like if you have search kick, you basically just add KNN into your definition, and you can just do vector search on that. Like this is the one-liner. So what do we need to do, like the entire feature? We need an embedding model, which we already picked. We need a vector database, which we already have. Now we need to have some embeddings, because we operate on those. Yeah, embeddings. Mats told us that the programming language for AI is Python, the end. Right? But we're Rubyists. We're Rubyists on the Baltic Ruby, right? We can do better than that. Yeah, so what are the options? If you want to think of the simple ones, you can use a provided API, you can do something like a wrapper for something like fast embed, or use Pycall to call Python, but that's cheating. You can shamefully hide a microservice written in Python. And then there is this guy. This is a blog of Andrew Kane, and this guy has been producing machine learning gems for like 12 months straight. He did 16, then I think another round of around the same number, and then he's like just pushing gems every single day, and most of them are machine learning. So this is his GitHub. You probably know his other projects, like small ones like PG Vector, extremely popular, SearchKick, PG Hero, Ahoy, Blazor. I don't think this guy is human. I think he looks like this in real life. Yeah, and he's written a wrapper for something called ONNX. It's pronounced Onyx, like a Pokemon. ONNX is like, no, that's too long of a definition. Let's do a TLDR. It's a portable open neural network format with runner available for multiple different languages, including Ruby. We're in the miscellaneous section. And it's often much faster than PyTorch. So if you want to run a model and you're writing, even if you're writing Python, you might want to use ONNX just because it's faster. So luckily, he's written a wrapper for that, as I said. He also had the same problem, like if I want to do some, model in Ruby, I shouldn't have to go through Python way of doing this. I could just do it in Ruby. As you can see, these are 2 lines of code to run a model, not that much. If you go to Hugging Face and you type ONNX, you will find a lot of different models, including the popular ones. But there is also a conversion tool. So if you have a PyTorch model, you can just convert it to ONNX and run it in Ruby. There is this Discord called Ruby AI Builders. And every now and then, there's like some random guy coming in and saying, I have this problem. And this particular person had like I want to scan images, like OCR them, but some images, like of documents, are rotated, and I don't know which ones. And if I put it into LLM, instead of telling me that the image is rotated, it will hallucinate the answer. And I look at it, I just went to Hugging Face, It took me like 2 seconds to find the exact model for this particular case. So tell me if the document is rotated. It has 12 downloads, but it works, and it's like a 1 megabyte. I told him, yeah, this should be fairly easy using this model. Here is a GitHub gist, and that's all the code that you need to detect if the document is rotated. And you probably even need less than that, because this was written by ChatGPT, not me. This was written like, one shot off. Like, it's literally 30 lines of code with the demo. So going back to embeddings, I did a workshop on image vector search, and during the workshop, we write 2 classes. This is the first one. This one takes, also by any kind of tokenizer for text, takes a model, runs a model on, in the method called, the last line, model predict, and outputs the first embedding. You can do batch embedding. That's the reason why there is a first at the end. And if you want to do images, it's even shorter than that. You basically take an image, feed it into model, you get an embedding, all in Ruby, nothing else. I know this is a native extension, but still, it's all in Ruby if you look at your code base. And if you're looking at an image preprocessor, this is like a glorified resize. There is nothing there that is like AI code. This is resized to a certain size and normalized the colors. So you don't have to ship your code in Python. It's useful to be able to read it, especially if you're doing those preprocessor or you want to take a look at the tokenizer, but you don't have to ship it. You can actually run this stuff in Ruby. This is the screen from the application that we were writing on the workshops. Sunset at the beach. Those images are unlabeled, and there is like 600 images from a free set, so basically it found some matching images. I also did the multilingual version because there is like a version of clip that happens to have a translator in front of it. So this is in Polish, a leaf at the beach, and it actually found the image. It has a much smaller distance than all the other images. So this is basically made by those 20-something lines of code that you saw in those previous slides. But image search isn't just image search. There's much more you can do if you have like a power to be able to recognize what's on images. You can do videos. If you want to do videos, you take this, and this now is videos. It's very easy. You extract the keyframes, and you embed each keyframe, and now you have images, and images are a solved problem. So basically, now you can embed videos, so you can search for unlabeled videos. You can do content moderation. Like if you prepare some examples of texts or images that you don't want on your website and user uploads something, you just compare those embeddings of those predefined examples with the new thing, and now you can filter out something from the moderation queue. Here's a great example that we did. Turns out the Eiffel Tower, the lights on Eiffel Tower are copyrighted, and you can't really put a free image of Eiffel Tower at night, but only at night. So you want to detect this particular situation, that the image is of an Eiffel Tower, but it happens to be in the dark time and there are lights on. What else? We can do duplicate detection. The traditional way of doing duplicate detection is called something called perceptual hashing, which is an idea from the 80s, implemented in late 90s. There is this thing called p-hash, perceptual hash, which is a library that has a gem that is popular but very difficult to build because of some native extension shenanigans. It compares images normalized to something like this, does the Hamming distance, and it's older than GPT, so it's not cool anymore. But it's still a great tool. But if you do a KNN, so K nearest neighbor, so vector search lookup as a second step, it reduces the false positives by 99%. Hooray. All of this looks very simple when it works. But going from web development to AI, machine learning development, is basically this thing, like doing proof of concept over and over and over again, because most of the code will be a throwaway code. We had to implement all of those to be able to find like a matching working set of parameters, and did some evaluation, did some benchmarking on those models. They are not like I just use a model and I'm guaranteed the result. I have to go through every single one of those and make sure that the results are satisfactory. Nothing is ever predictable. This is AI rendition of XKCD about machine learning, which is basically you stir a pile of stuff until the answers on the other side looks right. And if they don't, you just stir a little bit more. That's how AI works. So if you if you search for photos of a white cat, you might have a white dog, and there is nothing you can do unless you train the model a little bit more, which is difficult to do with Ruby. We don't have this part yet. But maybe soon. Data is everything. So if you want to go into AI and machine learning features, prepare your data, clean up everything, make sure that you don't have any trash in your database. Define what's better so you actually understand what the goal is. And yeah, this should set you up for doing some AI work in Ruby. But there's more. There's a bigger picture to explore. Ruby plus AI ML is a great match. LMs are awesome, but there is more. And I think that if you are looking at the problem that requires some machine learning, you should make Hugging Face your second Ruby gems. Thank you very much.